Hello, everyone. Welcome to the second installment in our Measuring Accessibility webinar series. I'm Michael Brennis, researcher with SSTI, the State Smart Transportation Initiative. The title of today's webinar is Advances in Project Evaluation. And we have two great speakers for you today that we'll get to in just a minute. In terms of housekeeping items, this session is being recorded and the recording will be available on the SSTI website shortly after we conclude. Today's session is available for AICP credit. So if you're interested in that, check the link that will be provided. And finally, we've got the chat disabled for this session, but if you have questions, and we encourage your questions, please type them in the Q&A feature, and we'll get to as many of those as time allows once we've heard from our presenters. The State Smart Transportation Initiative promotes transportation practices that advance environmental sustainability and equitable economic development while maintaining high standards of governmental efficiency and transparency. And we do that in three ways. First is our community of practice, which is a space for state DOT leadership to share challenges and best practices with leaders from other states. We conduct knowledge sharing, which we're doing today via this webinar. We also publish a blog and newsletter examining applications of current research, trends in travel behavior, and other transportation and land use issues that our audiences may find interesting. And finally, we conduct research and offer technical assistance to agencies interested in what we provide. If you're interested, sign up for our newsletter at ssti.us. And if you wouldn't mind, at the end of this webinar, take the survey that's distributed. That'll help us improve what we do. We'll assume today that most folks in attendance have some familiarity with accessibility analysis. Accessibility analysis, sometimes referred to as access to destinations or access to opportunities, allows us to better characterize the extent to which people can participate in our society. We've seen exponential growth in the number of papers on the subject published in the academic press, and accessibility tools have become more widely available as the tools have become more widely available, and as users have broadened their understanding of how accessibility analysis can be applied. In practice, we've seen a burgeoning interest in incorporating accessibility analysis into both performance metrics and project evaluation. We here at SSTI are keenly interested in how accessibility analysis can be operationalized by state agencies. For those interested in exploring these tools and techniques further, a quick plug for the SSTI Measuring Accessibility Guidebook that's available at our website. Today, we will hear from two practitioners working with state departments of transportation about how they're advancing the use of accessibility metrics to evaluate projects from a number of different perspectives, including the use of demographic data that will be of interest to those of us concerned with equity in transportation. In the first segment, we'll hear from both presenters about their experiences developing and running a recent Transportation Research Board workshop. And then we'll hear from our presenters individually about some of the opportunities and challenges they've encountered at their own agencies as they advance the practice of accessibility analysis. Our speakers today, Ali de Alquaz is a senior planner working in the Office of Transportation System Management at the Minnesota Department of Transportation. She applies her interest in GIS and data-driven planning to her work through performance measurement and multimodal access analysis. Henry McKay is a sustainable transportation analyst at Caltrans in the Director's Office of Equity, Sustainability, and Tribal Affairs, where he works on the development and implementation of modal access to destinations, project performance metrics, and equity-focused spatial analysis tools. With that, I will pass the baton to our first presenter, Ali. Welcome.
Thanks, Michael. Let me get my slides up here. All right, so as Michael said, I'm Ali de Alquaz. I work for the Minnesota Department of Transportation, and Henry and I are going to kick this off by talking about our Transportation Research Board workshop. So a little bit about the conference that the workshop was held at. It was the Innovations in Travel Analysis and Planning conference, which was the first under that name. It joined two conferences together to join practitioners and researchers. It was held in Indianapolis earlier this month, and in a fun twist of events was held at the Union Station in Indianapolis in the sort of restored portion of the train station. And so the conference, if you can see it behind the slide, was held in a beautiful building and a fun venue for transportation planners. The workshop itself was developed from a conversation we had during a joint MnDOT Caltrans technical advisory committee, where Eric from Caltrans and Anson Stewart came up with the idea to pose a question to folks in the industry to try defining accessibility indicators by exploring example projects and looking at the various options and variables that come with accessibility analysis. Those include travel mode, travel time cutoff, travel time decay functions, bike level of traffic stress, lots of variables like that. And so in summary, me, Henry, and Anson ran the workshop both in person, and Henry was virtual. And we'll get into a little bit more of the details of what the workshop was. But first, we wanted to touch on the Caltrans MnDOT Accessibility Analysis TAC, which was held in late 2022 over 3 sessions. The sessions were focused on networks, land use, and metrics. It brought together a really great group of experts in the field, including those in sort of the academic sphere, as well as practitioners and planners from across the country. What came out of the 3 TAC meetings was the document on the right-hand side of the screen, which is a draft version of a write-up of what the experts came up with, which in short was beginning to standardize accessibility analysis in terms of what performance measures are used, what sort of assumptions are used for bike and walk speeds, lots of assumptions like that. We really dug into it in a lot of detail over the 3 meetings and came away with a really great summary document that has been foundational for us at MnDOT and for others across the country in this work. And as Michael said, we're going to just reiterate and ground everyone in what we're talking about today, which is access to opportunities. Goes by so many names here at MnDOT. We like to call it multimodal accessibility analysis. It's also access to destinations or a handful of others. But what we're talking about is always the same, which is a measurement of origins, destinations, and the travel between them. Today in particular, we're talking about that with the added level of project evaluation. So we're looking at how changing the transportation network impacts one's ability to access destinations. So going back to our TRB workshop, the primary task that we asked of folks was to rank 4 example projects, which I'll describe on the next slide, in order of most to least equitable access to either jobs or grocery stores. So we asked them to look at a handful of results from the 4 projects that we developed, dive into it using Henry's post-processing tool, which he will go over in more detail. Think about what accessibility means to you, define that indicator, which could be something like access to grocery stores in 15 minutes on a bike for people under the poverty line or people in total. And then apply that to all 4 projects, rank them in terms of their impact on accessibility. And then the secondary task that we asked of folks was to critique the process of ranking projects or project evaluation, and also think about different areas for future research or just generally discussion among experts or people new to the accessibility field. The right-hand side of the screen is sort of that 3-step process, which I basically just went over, but essentially pick an approach to what accessibility means to you and your group. Step 2, use the post-processing tool to come up with the metric values themselves. And step 3, rank the projects and come up with your justification as to why you believe that accessibility metric is impactful and why the ranking makes sense to you. So the 4 projects that Anson, Henry, and I developed, which are illustrative examples. They're kind of based in reality, but there's no commentary on whether this should happen or not. The 4 projects are Blue Line BRT, which is a planned BRT line, runs east-west in Indianapolis, which is the blue line on the map. The second project is North Meridian, grade separation project, which runs north-south on the yellow and black line. Then the Downtown Infill Development and Cycling Improvements Project, which is the sort of red V or Y shape on the map. And then lastly, the Pennsy Trail Gap Closure, which is an existing trail where the line is solid and the dotted line is where, or sorry, the dotted line is where it exists and the closures are the bold line. So we chose these 4 projects because we wanted them to sort of be realistic projects that people might come across either in their professional or personal lives as you're traversing the transportation network, and also that they're sort of at different scales and focus on different modes. So how do we take projects that are focused primarily on different modes, like the Meridian project is focused on auto and others are focused on bike ped? How do you compare across for pretty unique projects? So talking about each one individually a bit more. The first one is the Blue Line project, where we basically improved upon what is the proposed transit accessibility of the Blue Line, so making it faster and having shorter headways. Second project, North Meridian grade separation. This one is primarily focused on auto. It's essentially turning a major thoroughfare in Indianapolis into a controlled access freeway with limited crossroads. So again, focus there, the impact is mainly going to be on auto with potentially detrimental impact to bike and pedestrians. The third project, just the downtown infill and bike level of traffic stress reduction. We looked at adding 2,000 jobs to a currently vacant site south of the zoo in Indianapolis, and also improving some of the bike network in the downtown area to be level of traffic stress 2 from level of traffic stress 4. So theoretically, people who are kind of average bikers would feel comfortable on those roadways after this project would be completed. So this brings in the land use piece, which is a piece that comes up in conversation around accessibility often, and that we thought would be front of people's minds at the TRB conference. So we wanted to include it, and also gets at how biking infrastructure can change the game in a downtown area. Then the last project was the Pennsy Trail, which as we showed on the map, currently exists in sort of little sections across the eastern greater Indianapolis area. It runs along the old Pennsylvania Railroad corridor, and we envisioned closing those gaps with shared use paths, which is what currently exists there, and also connecting into the downtown via an existing shared use path along the Pleasant Run Trail, which is also a river, and then connecting directly into downtown on Alabama Street. Like I said, all of these would be very low traffic stress, shared use paths, direct impact on bike and pedestrian accessibility. Although in this case, since it's so far into the greater Indianapolis area, there might be a limited number of people who live there or a limited number of jobs. Again, Henry Anson and I did not have local context on Indianapolis, so we weren't quite sure what would come from these projects. And then we will hand it over to Henry.
Great, thanks, Ali. So Ali just sort of laid out what the hypothetical projects were. For each of those 4 projects, we did an accessibility run across all 4 modes. So transit, walk, bike, and pedestrian. And then for many of them too, we did bike access to transit and walk access to transit. Within that, we did it for different sort of parameters, so different travel time cutoffs, and then having the destinations decay weighted by travel time, and then just sort of hard cutoff, like how many jobs can you reach in 15, 30, 45, 60 minutes. So we also provided, project spatial data in shapefile format, as well as several weighting factors for the analysis that I'll talk about in a minute, looking at different demographic groups. So all in all, just on the project accessibility side, I believe we had somewhere around the order of 700 unique kind of options to choose from, which is quite a lot for 4 projects. So we provided, the post-processing tool, which I'll talk a little bit about more in a minute, to actually run the analysis, all the data, so kind of every possible combination of analysis that you want to maybe do within kind of a reasonable set of parameters. And then, other resources like the companion document that Ali mentioned from our technical advisory committee, and some other background information just on, kind of lightly pointing to some of the assumptions we would perhaps make. But the idea here was really to provide a lot of information in kind of a simplified structure to really get, participants to have to think critically about what parameters we're going to choose and why. No one would have time to run all the different iterations here and see which one, deliver different results. It was really key to kind of theoretically decide on a path forward and then run some projects and rank them and see how they compare to other groups and think about why that is and what the benefits and drawbacks are of all those approaches. Next slide. So I'll give a quick rundown about the actual post-processing tool that we built and provided to teams, as well as some of the kind of project rankings that came out of this. So the tool we built is really simple. It's based in R, and it's hosted with the R Shiny platform. And it basically allows you to do really simple accessibility project analysis and look at outputs like percent change in access and average change in access and weighted versions of both those things. There's quite a few tools that have these sort of capabilities out of the box. And this type of analysis is fairly simple to conduct in ArcGIS as well. Really what this tool kind of allows us to do, and the reason we developed it, is because the state DOT level, your kind of political study area usually is the state or large portions of the state. So, practitioners conducting accessibility analysis on like the county or city level, it's easier to just see how a project impacts your whole county or your region, because that's a pretty manageable geographic area to compute accessibility for. Since we're doing things at statewide scale, we kind of had to develop methodology and guidance around standardizing those study areas in a way that's kind of agnostic to political boundaries, since we have a lot of projects that cross counties and districts and things like that. So that was a big reason we developed this tool, but it's been useful for other applications as well. It's quite simple and just takes as inputs just your project name for kind of organizational purposes, and then basically a baseline TIFF file and a project TIFF file that represent just your kind of baseline conditions and your build conditions for cumulative accessibility. This tool is kind of designed to work really well with Conveil, which is an existing tool that actually can produce accessibility outputs. You could do this with other platforms as well, though, theoretically. And then we also have an input for weighting a weight TIFF. So, if you want to weight your accessibility results by just where the general population lives, for example, or where workers live, or bring in some of those specific demographic groups to look at equity. And then it primarily functions by taking in a project shapefile. We're going to convert that to just GeoJSON because it's a lot easier for most people, I think. But taking your project alignment shapefile and then building sort of a buffer around that at specified distance to define a consistent study area across modes and across projects. And on the output side, it really just gives you a few metrics. Percent change in access, which is kind of a good relative measurement. So even small changes can be relatively big if kind of your baseline is low. And then average change in accessibility, which is looking more at what the raw numbers are at play. And then we present weighted variance of both of those, which are probably going to be the metrics that most people look at, and it's certainly the ones we're using in practice. So looking at how, is accessibility actually accruing in places where people live is important. And then we also have a map, an interactive map tab on this that is useful just to kind of do gut checks on, am I actually running the project right? If you see a lot of negative numbers or kind of weird results, that's usually an indicator that the project was coded incorrectly or the outputs are wrong. And so that's a good kind of check to go make sure things were done correctly. Next slide, please. I will note the link for that tool just got put in the chat. So it's kind of a work in progress, and we'll be pushing a lot of new updates to it soon based on feedback from this workshop. But it's a good open source tool to do some of this stuff. So I would encourage anyone who's interested to go check that out on my GitHub page, and feel free to use it. And if you have any feedback or suggestions on it, feel free to reach out. So this slide just shows real quick what those actual weighting factors were. Again, we have all the actual project accessibility info on what the build and baseline is, but there's quite a few options in terms of how you actually weight that. And so these were the ones we provided for the workshop, looking at just general population density, worker density, and then looking at white and non-white population density, and then trying to get it sort of low income by looking at the density of people under the poverty line and over the poverty line. This is sort of a generalized example. This is one of those cases where kind of local knowledge is really important, and you would probably want to dial in specific weighting factors based on exactly what you're trying to analyze and what's significant in your region. We have slightly different versions of this, for example, in California that we use. Next slide, please. So here's an example of just, I think, how one group ran a project and kind of what the basic thinking is. So the Blue Line BRT project that Ali mentioned again is a pretty, I'd say, relatively high impact transit project in Indianapolis that we kind of modeled as a hypothetical example. And so one way you could look at this, and what one group did, was looking at how does access to grocery stores change in 30 minutes by transit for people, let's see, under the poverty line. And in this case, they drew their buffer area of what they were defining as their project study area is 10 kilometers, which is fairly narrow. This is a really important parameter to kind of calibrate your metrics, especially when you're comparing different modes against one another. And so we have a specific way of doing this, but there's a lot of valid ways of doing it. And basically, the more narrow you draw that study area, the higher numbers you get, because you're including less, zero change places. But then again, if you want to be kind of capturing some of those more regional network effects of a transit project, you would want to be looking further out in terms of the study area. So these outputs here show what those actual metrics were for that project, as well as what the change in access was. Next slide. I think we're a little short on time here, but I'll go through this really quickly. At the end, we had all the groups rank all the projects according to the indicators that they developed. And then we took a pass beforehand at ranking all the projects according basically to the best guidance from the technical advisory committee document. So we did kind of arrive at some general conclusions about what some best practices are, although it's still fairly subjective and there's disagreement in some cases. And so in this case, the Blue Line project, the BRT project, was just pretty overwhelmingly the highest scoring across all metrics you could look at. And the Trail project was generally the lowest. The grade separation was the lowest because while it did increase auto access a lot, it decreased access for other modes because of the grade separation component. And then the infill and the Blue Line project, the infill and the Trail project were kind of tied in the middle. And so most people kind of arrived at the same conclusions we did, which was good to see that people were kind of taking that approach. But one sort of thing we were thinking about for, if we do this again, is to pick projects that are more comparable and more subjective, and so that, they could kind of fall in different orders depending on more nuanced, weighting factors and parameters you choose. Next slide. So I think we have a few more minutes left on this section. We did have a few key takeaways that Ali and I will discuss. A few main ones from the discussion we had with the group were, the value of these type of rapid response, sketch planning tools and deliberative planning and analysis really make it a lot easier to kind of see, what kind of metrics you can come up with and how they make projects look different, and what the benefits and the drawbacks of each one are. Also the necessity of local knowledge, though, in determining some of this stuff. A lot of the input on what specific metric you would choose and how you calculate that, while there is kind of good general best practices, can depend on what local priorities and knowledge entail. Allie, do you have any other thoughts on this first sort of takeaway?
I think you summarized it pretty well. I think what I would add to the conversation is that this was sort of a logistically challenging workshop, but proved to be quite beneficial in terms of what discussion was produced from it. And even the discussion of like, well, how do we use this tool? How does the post-processing tool work? What are all these different data layers? It really brought people into the accessibility space and understanding what the results are from the project. And within 2 hours of the workshop running, people were just running with the conversation, and we're able to have pretty detailed discussions about the implications of various outputs, and kind of all came, like Henry was saying, all came to similar conclusions, even though the projects were so varied.
Yeah, I would say another big takeaway was kind of the difference between the larger theoretical differences between sort of predictive modeling and measuring. A lot of people at the workshop were, I think, more so modelers by training, and in my work, even in Caltrans, like sort of explaining and communicating the fundamental differences between predictive modeling versus measuring what potential outcomes are, I think is a pretty different thing. And we did get a lot of feedback on like, how do you validate this, and sort of more feedback that would be geared towards like calibrating a model. And I think there is room for some of that in here. And with big data and stuff, we are definitely interested in looking more at the intersection of that. But it is kind of fundamentally, in some ways, a different thing. I think those differences were definitely highlighted.
Yeah, I think there was a lot of discussion that led to sort of us and Anson reiterating the value of accessibility analysis and how it differs from that modeling, or other ways of doing similar analysis. So hopefully we hit that home for folks who were in the audience of the workshop. Another one that I think Henry touched on was just the complexity of joining and combining and comparing different modes. That was really difficult for some people, as well as us, and I think was a key conversation that went on.
Mm-hmm. If anyone has any questions about this portion of the workshop, or I know Allie and I both have some other things to discuss, but we can pause on this one for a sec.
Yeah, I was going to just ask a quick question before we transition to the individual presentations. When you bring this kind of stuff in front of practitioners who have different, levels of capacity with it, the question arises: did you gain any insights about or any thoughts about the utility of accessibility analysis in standardized processes versus its use only in special cases?
We had one audience member, workshop member, who kind of came in defense of accessibility analysis. There was a lot of discussion about, well, we don't know what people actually do, and we'd like to understand that better. And somebody brought up that they worked for an MPO and that this would be an incredible tool to bring in this workshop format in a simplified version to their senior leadership, and to run them through that quickly so that they could really understand what accessibility analysis is. And they also pointed out that it could be something that was done continuously. So one, helpful in getting them on board, and two, helpful in terms of getting into their decision-making process.
Great. Well, with that, I think we'll transition to the individual segments of the workshop. And by coin toss, I think Allie gets to go next.
Yes, let me share another screen. All right. Ooh. There we go. I think that's working. Okay, so accessibility analysis at MnDOT. We wanted to start out by talking about some of the foundational work that we are building upon. It's with a lot of that work is with folks on this call, I imagine. Other MnDOT staff, Accessibility Observatory at the University of Minnesota, SSTI, other DOTs like Caltrans and MassDOT, and plenty of others. The right-hand side of the screen is a bunch of the work that we have on our performance dashboard, as well as work that has done by others like SSTI and jointly with SSTI and us at MnDOT. So we just wanted to highlight that there's so much work that goes into this, and that has led us to being able to implement accessibility analysis at the project evaluation level. So to talk about what we've got going on at MnDOT now, we've got two work groups, still focused on workshops. The first group is Multimodal Accessibility Technical Team, affectionately called the MAT here at MnDOT, and they are building pretty much directly off of the work of both the SSTI guide as well as the MnDOT Caltrans TAC, working on standardizing the analysis for, in the Minnesota context, developing performance measures, so building directly off of performance measures that were identified in the TAC and choosing ones that we feel are appropriate at the for the decision points that we have identified, integrating into MnDOT decision making and developing guiding documentation. I'll talk a bit more about each of those further into the presentation. The second group that we have, which is a little bit more informal but equally as important, is the Multimodal Accessibility User Group. So I have been onboarding folks in kind of two capacities to multimodal accessibility analysis using Conveil. The first is getting people directly into the analysis, getting them into project evaluation, learning the standards of analysis in terms of how we draw our edits, both in Conveil and in JOSM, if we're doing some more detailed analysis. And then the more informal form of that is bringing folks into the world of accessibility analysis, teaching or showing them and teaching them the ways of how we do this in terms of methodology, but not necessarily bringing them actually into, we want you to do the project analysis for us. And the reason I bring that second portion up is that those people are key like experts in their own field. And then when we can bring them on board to multimodal accessibility analysis, they become literate in both spheres, their area of expertise and accessibility analysis, and are stronger at the table, both for us and for advocating for their own work. So that has been key. At MnDOT, we see three critical levels of application. The first is the state and regional level, which is a little bit of what I touched on in that intro slide, using the accessibility analysis data, statewide data showing accessibility on an annual basis. We can show change over time, even in a PDF form or in some of the measures that are included in the reports from AO. And then the second level is MnDOT's program. So this is looking more directly at the roadways that MnDOT manages, and we can look at how the improvements to those roadways are changing access for the different modes. The third one, which is the one that we're talking about today, is project alternatives or project evaluation. So here we can look at how the different alternatives that are being proposed impact accessibility. And I'm going to get into that on the next slide. So we see three key points of decision making, or points where we can sort of insert accessibility analysis. The first being corridor planning and alternatives. So that's in the sort of young phase of a construction project's life. The scope and scale of the project might be more broad at that point, but we can still go into a program like Conveil for us, or a multimodal accessibility analysis program generally, and look at how the intent of that project might change access for those around it, and look specifically at different demographics of people or different destinations. The second is the pre-scoping alternatives. So this is when the project has been more defined and we can refine the analysis we did in the corridor planning alternative stage and look more closely and provide more sort of accurate results of how access might be impacted for those in the project area. And then from there, we see a pretty great opportunity in the post-construction phase, where we can look at projects at an annually and see how they impacted accessibility across the state or in particular regions, depending on what was actually constructed. So some of our current efforts, which I'll go over quickly, are we're working on messaging internally. We've got a couple of documents in the works, the first of which is a summary, which we'll use to kind of share what multimodal accessibility analysis is and message it towards those in different districts as well as other offices across MnDOT, to bring people sort of up to speed on what we're working on, and in particular how this work relates to work that is ongoing and that we are building into, rather than just adding another tool onto everyone's plate. We want to be very intentional about, coming together and working together towards a common goal. The second messaging piece will be more geared towards those actually doing the analysis. So it'll be sort of the MnDOT accessibility guide. All of this builds off of the SSTI guide as well as the Caltrans MnDOT TAC documentation. The second is the performance measure, our performance measures. We've identified 2 of, I believe, the 4 that are in the Caltrans MnDOT TAC. So it'll be percent and average change in access within the project area. And for now, we are calculating those using the post-processing tool that Henry touched on. The third efforts we have going on are projects. I have 3 listed on the screen. These are some of the more recent ones that we've done. Really briefly, the Pell on 65 we did with SSTI and was sort of our first foray into a really complicated project where we used JOSM to put in congestion speeds and do really detailed editing to make sure we were being as accurate as possible for one alternative of a handful in this case. So that was very foundational for us at MnDOT to get that capacity. And then US 169 was our first project we did it was already constructed, so we rebuilt the baseline network and looked at how accessibility was changing over time. And then Trunk Highway 47 and Trunk Highway 65 was sort of a unique one for us, where we were looking at crosswalk prioritization. So we had a list of 25 crosswalks along those 2 trunk highways, and kind of pushed our knowledge of how to do accessibility analysis in order to prioritize individual crosswalks rather than look at them as a whole. Another project that we have done, which is in sort of draft form and was experimental, was the Blotnick Bridge in Duluth, Minnesota, where we looked at adding a trail along the Blotnick Bridge to connect Duluth and Superior for biking and walking. There's some assumptions on the right-hand side of the slide. The most important one is that we were looking at max level of traffic stress at LTS2, so looking at the more average bike rider along the trail and how access would increase for them. So here are the results. You can see anywhere that's sort of pink is increased access. So in Duluth, there's increased access north of the trail because it's connecting into an existing city trail. And then you can also see there's just a little bit in Superior on this southern portion, in the northern portion of Superior. There's just a little bit of pink there at 15 minutes, and at 30 minutes that sort of explodes. People would have a lot greater access into Duluth and Superior. And the same is true when you start in Superior and go into Duluth. So touching on equity for a moment, MnDOT has been doing a lot of work around transportation equity, including the recently published transportation equity definition, which is on the screen. And so we are hoping to build upon this work, which is also in other state plans like the pedestrian plan, and probably most importantly, the statewide multimodal transportation plan. There's a huge amount of effort going into this, and we want to make sure that we are incorporating that and building upon it. A couple ways that we're looking to do that is by incorporating other existing tools like priority areas for walking tool, or PAWS, which is the right-hand image of the map of Minnesota. And then the second way is to incorporate non-work destinations. So right now we're primarily focused on access to jobs, but we see huge opportunity to look at the destinations that are most important to Minnesotans, and some of those have been identified in the statewide pedestrian plan. And so we will be looking to add that into our analysis as we move forward. Last slide here, takeaways. Multimodal accessibility analysis tells a super meaningful story. Even if you're not using hard numbers like we didn't for Blotnick, we were just looking at the narrative, looking at the maps, the isochrones themselves, and it tells an important story about how access changes over time and with changes to the transportation network. Also, internal and external partners have been key to success for us at MnDOT and really encourage that of others who are interested in doing this type of analysis. Next steps for us, we're going to look to finalize and formalize our messaging, ramp up our analysis capabilities in terms of getting more users into Conveil, and continue incorporating equity.
Thanks, Allie. That's great work there. Very interesting. We're going to pass the baton now to Henry McKay at Caltrans.
Great. Thanks, Michael. Thanks, Allie. Let's see. All right. Can everyone see my screen?
We can see your screen.
Fantastic. So today I'm going to touch on just two kind of key efforts that we've been engaged with recently around accessibility. Some bus priority analysis and the Caltrans Transportation Equity Index. Both of these are slightly different than the kind of conventional project analysis that we was the subject of our workshop at TRB. We're still working a lot on that actually, and I think the TRB recap kind of covered the general concept of that. So I want to highlight sort of a few other types of analysis we've been working on. First, I'll talk about a bus priority analysis we've been doing. I guess this is sort of under the umbrella of project analysis, but one of the big things about the project analysis work is looking across modes and looking at, combinations of modes for bigger projects that include bike and ped components along with highway components. This was slightly different in that it was basically trying to compare 6 alternatives for bus priority projects, and more specifically bus lanes. And it also brought in sort of more granular transit data that was really interesting. This was also one of our first efforts working with other sort of entities within Caltrans. Specifically, we have a group that does a lot of work around GTFS data, so transit data, including GTFS real time. So looking at what actual bus speeds are, in congested areas where buses get stuck in traffic. And so what our methodology here was to use their data and look at what sort of the worst case scenario bus speeds were along certain corridors. So looking at the 20th percentile all day speeds, under the assumption that people usually plan bus trips around unreliability. And so if the bus is always late, people tend to account for that. And then we set target bus lane speeds based on regional context. And so from research and other work, looking at if we put an exclusive lane here, what would the average speed be in that case for the bus? And then we calculated using those differences in actual observed travel time to assumed bus lane travel time, how much travel time savings would occur over the course of the service day, and in turn how many additional trips could be run. So if you run everything on a frequency, you gain a certain number of additional trips and save travel time. And so the assumption being how much more service could an agency run with existing resources because of travel time savings from a bus lane. And so with those inputs, we were able to run an accessibility analysis that accounted for both the increased speeds as well as the increased frequencies that would be enabled by those operational time savings. In a lot of cases too, the bus lanes are pretty short. And so the actual time savings for an individual trip are fairly minor, but do have a minor accessibility impact. But really those increased frequencies play just as much of an impact because people on average are going to be waiting less time for the bus. So we kind of ran all these projects through just every metric we produce, which at this point is quite a lot. It's all the metrics we discussed for the TRB presentation, so average change and percent change, but we run that for both work and non-work destinations, and then for a number of different weighting factors to look at equity. And in this case too, since we did have some really rough cost estimates, we were able to look at kind of a cost benefit metric of cost per average new job accessible or cost per average new point of interest accessible. So just an example here of one of those projects, Santa Monica Boulevard, which you can see here on the cost benefit metric was basically kind of one of the higher scoring ones. The actual percent change for it was fairly low because transit access is already pretty high there. But it actually, for the length of the bus lane and the amount of additional frequency that it would unlock, provides a lot of benefit. And so you can see here, we put in the projects, and then we get our metrics using the post-processing tool. One important note here, just on methodologies, you can see that we set the buffer area to 50 kilometers. And that's roughly equivalent to the amount, if you took the average sort of free flow bus speed with a bus line that we were assuming, which is about 16 miles an hour, it's where you can get in 2 hours. And so our analysis runs out to 2 hours. And so in theory, we want to include every area that theoretically could sort of be within the sphere of influence of this project. So, in turn, you'll see that this returns a lot of pretty low numbers. If we, made that study area, 5 kilometers around the bus line, we'd see really high numbers. So this is one of those important sort of decisions that have to be made about what assumptions you're using. In this case, though, it was a lot easier because we're just looking at bus projects, and so we're able to kind of do that consistently across all projects that were the same type and get a pretty good relative sense of how things were performing. It gets a little bit more tricky when you're comparing this to like an auto project and a pedestrian project, but that's still the rationale for setting these study areas based on sort of set distances. So you can see here, just one of the outputs as well from the post-processing tool on the map side. You can see the change in travel time weighted job accessibility. Again, it's kind of mostly along the corridor, but you can see, areas all along the corridor, even, miles away from where the actual project is occurring, are getting a lot of benefit from this. And as well as you can see kind of the network effect too, barely, it's pretty light here of, other places all around the city are getting slight increases in accessibility just because of this one improved route. So the key takeaways from this analysis mostly were, that accessibility is a really powerful way to analyze the benefits of transit projects. But in this case, it really wasn't the only metric that we wanted to use. So, the other key metric that we've been developing, or actually the other team that works mostly with transit data has been working on, that we've been involved with, is looking at transit delay. So looking at other metrics that are valuable, like daily minutes of delay, then looking at how that relates to ridership and whatnot. And so in these cases where we're trying to speed up the bus, those metrics are also really useful and don't necessarily correlate one-to-one with accessibility. On the equity side too, we've wanted to take a deeper dive on equity with this stuff, and we actually did run all these projects, weighting the results specifically by priority populations. And what we found was that the results were fairly similar in projects with, the ranking changed slightly, but for the most part, it was fairly similar. But in some cases like this, this kind of high level accessibility analysis isn't really super adequate. I mean, you can analyze, how accessibility is changing based on characteristics of a residential population or, where people work or whatnot. But really that doesn't necessarily match the exact demographics of the people that are riding the bus in that area. Just because a project's slightly disproportionately serving, a wealthier area doesn't mean that all the people in that area that ride the bus are high income. And so, in this case, our real recommendation was, look, like we have the technical capabilities to do the analysis, but it might be more valuable just to look at what the actual demographics of the bus ridership is. And this, the project that's actually just going to, make the bus better and increase accessibility the most is probably going to have the greatest, equity impacts, regardless of, the specific exact outcomes of the accessibility analysis. So in some cases, equity, the equity weighting, equity look of the accessibility stuff has been really valuable. In cases like this, it was clear that we kind of needed to look a little bit deeper into the actual information on who's riding the bus and where those benefits are going. I'll touch real quick on just the equity index we're working on as well, which is sort of a statewide screening effort to identify areas that are lacking in access amongst other criteria as well. Specifically on the accessibility side, we've just finished operationalizing a few new indicators to do this statewide that I'll touch on briefly. We'd like to publish more information about this pretty soon, hopefully, and make data and methodology available to folks who are interested in doing similar things. But we have 3 indicators looking at transit, pedestrian, and bicycle accessibility. On the transit side, we're looking at the ratio between transit and auto accessibility, and so looking at what that gap is. And you can kind of see here the isochrone and what that looks like. But then we calculate it for, grid cells statewide. And you can see where that ratio is highest is in like San Francisco and the Bay Area, at least in the Northern California example here. On the bicycle side, the way we've operationalized that is looking at the gap between the low stress network and the high stress network. And so here you can see the isochrone as well, showing that, of course, if you're willing to bike on the high stress network, so basically biking anywhere, you can get generally a lot further and get to more destinations than if you're only willing to cycle on the low stress network. And so this is, meant to sort of identify gaps for, these kind of normal cyclists who maybe aren't willing to bike on really high stress facilities with poor infrastructure, and to help improve those gaps. And you can see here again, kind of where the outputs of that are. Davis, California, for example, scores very highly here. Many parts of Sacramento score lower because there is a lot of network, but it's generally high stress in some places. And then on the pedestrian side, this is the one we've done the most work on. We're basically working off of previous work that SSTI actually did, and developing that a little bit further for our specific context of identifying the gap between just where you could get all the pedestrian network shown here in sort of the red isochrone and the ideal access sort of catchment area. And so just looking at it, if you could walk in a straight line anywhere, where would that get you? This does raise some sort of technical issues around, especially when you're doing weighted access, weighted by travel time. It's not as simple as just drawing a buffer. You have to kind of still calculate those individual basically OD pairs and then weight them. And so we did develop some tools to do that. And they function pretty well statewide at this small pedestrian scale, but if you were doing this for auto access, for example, it would probably be difficult to calculate on your just like work computer. You'd have to scale things up. So you can see here, this calculated statewide as well. The important thing about these three indicators is they tend to highlight different places and are really focused on identifying where are the transit gaps, where are the bike gaps, and where are the pedestrian gaps, because those often are different things and sort of require different solutions. So we can overlay these and see where the sort of persistent gaps are across all three, and what areas score well on all three. So this is ongoing work, but is going to be in our forthcoming equity index that we're going to release the version 1 of fairly soon, hopefully in the next month or so. So key takeaways here, we're kind of, the importance of defining relative accessibility measures. You'll notice that all these are calculated statewide. And so we really like using ratios in this case because we need to define what's good accessibility for this specific context. And those contexts vary widely throughout the state. And so the importance of doing this all on a relative basis is really key. And then lastly, with the computational side, some of these analyses are really difficult, especially looking at that difference between the network and the crow's fly. That was something we spent a lot of time trying to kind of figure out how to make actually run on a granular level statewide. And so we'd like to make efficiencies to that in terms of how we compute it, because it is fairly slow right now, but we do have some tools to do it fairly quickly. And I think I'm a bit over time, so that is all I have. Thanks.
Thanks very much, Henry. We do have a couple of questions that I'd like to get to. Apologies in advance if we go over our time by just a couple of minutes. The first question goes back to the tools themselves. Can you talk a little bit about what's the state of the art with the tools in terms of analyzing access to goods and services, what we might call POIs, points of interests? Where are you each in terms of incorporating that sort of analysis?
We've incorporated it. I mean, the first issue is like getting the data. There's a few sources that sell it here. Google. There's also a lot of publicly available sources for sort of individual points that you can compile in theory into an index. Once you get into non-work access, it kind of opens up a whole other lane of questioning around, do we weight an ATM the same as a grocery store and those types of questions. So there are different, a lot of questions around that type of thing come up once you get into that. And so we do weight things differently and do some data cleaning. Also, most of the sources you get for data for non-work are slightly out of date. And so from like a communication standpoint, it's difficult because a lot of times we'll share things and people immediately go to their kind of neighborhood and find a few little inaccuracies and kind of question the whole thing. And really what we're concerned with is like that the statewide kind of distribution is working well. And there are going to be inaccuracies in those things. And I mean, look at the jobs data, that has all the same issues. So we're really concerned with, that areas aren't being kind of underrepresented in those higher level questions, and less so on the, is this store that closed 2 years ago still in the data set, and how do we remove all of those examples? That would be pretty impossible.
Yeah, at MnDOT, we are in the we have in the works, bringing in other destination types right now. We're still working on sort of those standardization methodological things. We are, we want to bring in other destinations. We think that's vital to this analysis, but are still working towards that. Like Henry mentioned, there's so many different data sets that we could pull from, and we haven't quite figured out which ones we're going to pull from. And we have sort of a draft list of those key destinations, but haven't finalized it and aren't quite sure which ones will make the top list.
It sounds like it also is something of a communication issue in terms of presenting your results to different interested parties and what they're concerned about, and whether they can ground truth your results exactly. The next question goes back to the workshop, and is about whether the results were the percent change results that people found. How sensitive were those to the different metrics that people chose? Were there divergent results between different approaches up to the same project? And then follow up, any plans to do the workshop again?
I can go first. We saw a couple of different results. Like Henry mentioned, there wasn't enough time for all of the groups to get to all of the projects. So a few of them just focused on one project or another, but the ones that were comparable, the differences mainly stemmed from the different demographic groups that they were weighting by. Henry, you can feel free to add to that, but that was the biggest difference that we saw.
It all depends on kind of what the demographic distribution is in your study area. So I would say generally for the Indianapolis example, and I think just generally across the board, the variance in percent change is smaller based on the demographic groups weighting factors you choose than the study area like parameter that you define in terms of how large an area you look at. And so we saw some differences because of both those things. But I would say the main we chose projects that were so radically different that they were pretty clearly fell within certain areas. So I agree with Ray. Like, I think next time we do this, if we do it again, we really want to pick 4 projects that are like very minor alternatives of a bike and ped project that all score really within the same range, where the variance can be entirely explained by the choices and less of the projects.
Yeah, and I'll add that Anson, Henry, and I are interested in doing it again and sort of iterating off of it.
Great. Well, let's wrap up with a more philosophical question, perhaps. Do you think accessibility analysis has been adopted to a level that will start shifting the focus of projects?
Yeah.
And if not, how do we get there?
I think at MnDOT, we're working towards that. We've got a lot of buy-in from important folks in the project evaluation sphere of MnDOT, but are still sort of on the uptake process.
Yeah, same. We're kind of in the process of getting it really implemented in some key processes at Caltrans. I think we've been doing this for about a year now, and have been really focused on just standing it up from like a technical level. I think we're nearing a good place on that. And so we've been kind of trying to implement it as we go. But yeah, I think we're getting close to it being, at least in kind of an advisory way in informing project alternatives, and then hopefully at least as a criteria in certain, project selection processes. I don't think it's ever going to be the sole thing, nor should it be. I think one thing I've learned from all this is there's a lot of other considerations, and it's not necessarily the best metric for every type of situation, but it's a really powerful one that is good for a lot of things.
Great. Well, with that, I'd like to thank our presenters today, Ali Dialquaz and Henry McKay. And thanks to the SSTI staff members, Megan Link and Chris McCahill, working hard behind the scenes to keep this thing rolling. Keep a lookout for future SSTI webinars, and we'll see you next time.